Entity Framework Code First Development. There are two ways to implement Entity Framework in your applications, regardless if it's a Blazor server app or web API or even a console app. With the Code First approach, you create your model classes that represent the tables in the database and generate a new database from that. With the Database First approach, you can use an existing database and generate your model classes from the tables in the database. In this video, we'll look at the Code First approach, but there's a link in the description below to the video on Database First development. For this demo, we'll use a Blazor Web App. You can choose .NET 8 or 9 framework, it doesn't matter. Our Visual Studio at the time of this video is version 17.14.2. For simplicity, we'll choose the server hosting model and per page or component interactivity location. The first step is to create our models, so we add a models folder to our project. Inside, we'll add two classes for the model's author and book. The author model has a primary ID property and an author name property. By default, if you use ID in the first property, Entity Framework will assume this to be the primary key of the table. If you're using any other name, then annotate above the property with the word key in square brackets. Do a control dot on it to insert the using annotations. The only odd property here is the books collection. This is a virtual property. It's not created as an actual field in your database table. Entity Framework uses this property to load the book records for the current author. However, this is not done automatically. It's done through deferred execution or lazy loading, meaning when you retrieve an author record, the list of books is not automatically populated. But once you try to read the books property, Entity Framework will populate the books collection for you. Next is the book model. We've added an author ID property for a foreign key. This is optional, but it will simplify writing queries. For example, retrieving all books for a specific author instead of first going through an author record and then retrieving that author's books. The book model also has a virtual author property that is lazy loaded when you need to look at the details of a book's author. Right. Before we create our data context class, we need to add the Entity Framework new get packages. You can do this through the command line interface and type out the add commands by hand, or simply use the tools provided by Visual Studio. Right-click your project name and select Manage New Get Packages. From the Browse tab, search for Entity Framework. We're going to install 4 packages. The first one is the Microsoft.Entity Framework Core package, which is the foundation package. Make sure you select the version that corresponds to the framework of your project. In our case, because we're still using .NET 8, we had to select a previous version of the package. Next is the design package. This is especially used in Code First development when Entity Framework needs to design your database tables from code. Then there's the SQL Server package, which is specifically for working with a SQL Server database. There's a bunch of others like SQLite, MySQL, Postgres, etc. Finally, you need the Tools package, which is used to create migrations for your database. Again, ensure that the versions of these packages correspond to your project's framework. With our Entity Framework packages in place, we added a data folder to our project where we create our data context class. Just a reminder, we're creating the models and data context here in the main project, but of course, if you intend to use an API, these will live in your API project instead. The data context class must inherit from DB context. We'll call our class myDBContext. IntelliSense will generate the default constructor for you. If it contains a reference to the connection string, you can delete that. We're going to place our connection string in the app settings file. Then IntelliSense should automatically pick up the 2 models and create the DB set properties for them. And because we set up a relation between the 2 tables in our models, Entity Framework will design the database tables with the correct one-to-many relation and foreign key. At this point, it's a good idea to build your project and fix any possible errors. In the appsettings.json file, we add a connection string setting. Inside, we added our connection string and named it DB library. We also named our actual database DB library. Of course, you'll have to configure your connection string for your own environment, but in our case, we're simply using the Visual Studio built-in database server. In the program.cs file, we add a line to get our DB library connection string from the app settings file. Then, when we add the DB context service, we tell it to use a SQL Server database, and here is the connection string. You should build at this point because our next step will be to create the actual database. First, we're going to create a migration file. This will tell Entity Framework how to create and update the database. Now again, you could use the CLI to execute the add migration command, but we're simply going to use our IDE's tools for this. Right-click Connected Services in your project and select Manage Connected Services. You'll see that Visual Studio has picked up your connection string. Click the ellipses next to it and select Add Migration. Give your migration a meaningful name like First Migration or Initial. Select your data context class and click Finish. After it's done, you'll find your new migration file under the Migrations folder. The migration file is named with a leading date timestamp and contains the instructions for how Entity Framework should create or update the database. Back in Manage Connection Services, right-click the ellipses next to your connection string, and this time select Update Database. Select your DB context class again and click Finish. Your database is created. We can go look at our database under View SQL Server Object Explorer, or if you're using an external database server like SQL Express, you can also use SQL Server Management Studio. Since our database is under Visual Studio's built-in database server, we can select Local DB, then go to Databases and select our new DB library database. Here we can see our two tables, authors and books. To have a closer look at a table's design, we right-click the table and select View Designer. This shows us all the columns in the table, the keys, indexes, and foreign keys, as well as the SQL that created the table. Next, we're going to create services to hold the CRUD functions for our author and book tables. While you could call the Entity Framework methods directly from your front-end pages, it's just more manageable and maintainable to have them in service classes. Especially if you start adding complex validations and business logic, or need to build data transfer objects from multiple tables. We add a class called Author Services. It's important to note the naming convention here because IntelliSense will use the name of the service to generate your CRUD functions. When we enter our class, IntelliSense will suggest the code for us, and we can simply press Tab to generate the code. Of course, it doesn't know which data context to use or where to find our model, so we can just manually fix that. We also need an interface class to inject into our UI pages. So this service class should inherit from the interface class, which we'll create just now. When we enter the interface class, IntelliSense picks up the methods from our service class and generates the method signatures for us. Again, we needed to tell it where to find our model. As you can see, by using proper naming conventions, your IDE tool makes development easier for you as engineer. Okay, so now we do the same for books. Add a book service class. Now we see IntelliSense picked up the data context class from the previous author service. We also add an interface class for the book services. All that's left to do is add the services to program.cs, which IntelliSense should pick up as well. Let's have a closer look at one of our services. The data context service we registered in program.cs is injected into the constructor of the service class. In the first method, getAllAuthors, it uses this data context and references the author's DB set. Then it simply returns a list of all author objects in the set. The second method takes an ID value as parameter and uses the dbSets find async method to return the author with the same primary key. The third method adds an author using the dbSets add method and calls save changes to update the database. Of course, all these methods require some proper try-catch blocks and validation checking, but that's not the purpose of this video. The last two methods call the dbSets update and remove methods to update and delete an author. Note that whenever changes are made to the database, we need to call save changes to apply any changes. So let's see how we use these services in our pages. We can quickly scaffold some CRUD pages for our application. Right-click Components and select Add Scaffolded Item. From Blazor, select Razor Components using Entity Framework CRUD. In the pop-up, make sure CRUD is selected for the template, then select one of the models. We'll just use Author and select your Data Context class. The process will add a folder to your components called Author Pages, and inside you'll find 5 new pages. Their names are pretty self-explanatory. The index will show a list of your authors and is generally the starting page from where you can add, edit, and delete records. However, looking at the index page, you'll see the scaffolded page tries to inject the data context directly into the page. Remove this and instead inject your author services. Also down in the code section, remove anything DB factory related. Quick Grid requires its items to be in an iQueryable list, so add an iQueryable list for the authors. Then in the onInitialize method, call your author services getAllAuthors. This will return a normal list of authors, so you'll need to convert it to an iQueryable list. You'll have to make similar changes to all the other CRUD pages. Remove the DB factory stuff and inject your services. Change the code section to use the author services. This is what the delete pages code looks like after replacing the DB factory, the details page, and the edit page. But what do we do if we need to make changes to our models? For example, let's add an email property to the authors table. All we have to do is create a new migration file and update our database. Right-click Connected Services and select Manage Connected Services. Click the ellipses next to your connection and select Add Migration. Give it a descriptive name. Here we called it Add Author Email. Then select your data context and click Finish. This will generate a new migration file for you based on the changes you've made in the model. The migration file has a timestamp followed by the descriptive name we gave it. Inside the file, you can see that it will add a new email column to the table. Back in Manage Connected Services, all we need to do is update the database using the latest migration file. Select your data context again and click Finish. The update is completed. In our SQL Server Object Explorer, we can confirm the new column was added to our authors table. Thank you for watching our video. For more tutorials on C#, hit subscribe and click the reminder. Give us a like so the video can be visible to more people.